Hey everybody, I'm very excited because I got a request for a video help on Newton. So let's jump into it. Um, Here's the question, and um, we can see that we're talking about compound interest, and we know that it's earning 9%. It's compound quarterly. That's important. It's not a number, but it's an important part of the question. And we must have 80,000 in 18 years. Okay, so I'm going to start with what I know. 9% compound quarterly. Target is 80,000. This is my APR, and I have 18 years to do it. So the compound interest formula is the principal times 1 plus the rate divided by the number of times it's compound raised to the number of times it's compound per year times the number of years. And the problem is we don't have P, we have the target, we have what it would be equal to, right? So the first thing I would say is Newton is going to show you an approach that is algebraic in its heart, and so I'm thinking, that we can do something here where we calculate this compound interest using the compound interest formula, and we see how it works, and then we kind of refine our approach. So, for instance, if I want to have $80,000 in 18 years, it's growing at 9%. I have no idea, but I'm going to start with $50,000. So I'm going to say 50,000, that's just a guess, times 1 plus 9% divided by 4 raised to the 4 times 18. So a couple of points here. This is very fluid for me because I know the compound interest formula very well, but I'm putting in the principal. This is the part that I don't know, the 50,000. And there's really the part that I'm solving for. The 9% is the APR, the divided by 4 is compound quarterly, 4 times 18 because it's happening every quarter for 18 years, so 72 times. So this ends up being two looks like $248,000, which is amazing. Way more than I need. And so this is my first guess was too big. Now, Excel can really speed up the process of trying to do this because I can say, okay, my next guess is just going to be 25,000. And I'm going to take that amount and I'm going to do the 1 plus 9% divided by 4 raised to the 4. Don't forget your parentheses here, 4 times 18. And this number now is about half the size of that. In fact, literally half the size of that. And so now I know I need to go smaller, but instead of rewriting it, I can just keep trying other numbers. Okay, 99,000, too big, 15,000. Now we're getting closer, 16,000, a little bit bigger, 16,200, too big, 16,100. And then at some point, the rounding becomes important here because I want this to the nearest cent, and I don't want to round to the final answer. So I really need this to be accurate. I'm getting really close here, but I need to keep going further. 16,150, 16,105, 16,100. We need to go bigger. 7, 16,109. 16,115, 16,118. So this is just trial and error. I'm just crunching this out until I get to the point where I'm getting really close now. 118.5, 16118.75. Holy Moses, that was it right there. Exactly right. And this is 3 cents too big. So let's go down. Yeah, I think, boy, not sure which one is better, the 74 cents or the 75 cents. I'm feeling like 75 cents, but they're both 2 to 3 cents off. The other one is a slightly closer because this is 3 cents off. This is only 2 cents, less than 2 cents off. Okay, so with some trial and error and some critical thinking, I got there. Now, what they're showing when you look at the process, and I'll just pick up the next one here. They're showing this equation, and then they're just doing a little bit of algebraic manipulation. So here they've got this whole chunk is the part that we know all the numbers for. These are different numbers, by the way. And then I'm just dividing this by this part. So I can do that with Excel too. I mean, Excel is essentially a calculator. We were just trying to approach it. I was trying to show approaching it without doing the algebraic manipulation. But basically, the way that would look is, let me clear my drawings here. If you want to follow what they're doing, you can do essentially the same thing in Excel. That up. So basically, I'm looking for this number. This part is all fixed. And I know 80,000 is my target. So I'm taking 80,000 and I'm dividing by the 1 plus 9% divided by 4 raised to the 4 times 18. And it looks like, yep, that's exactly the right answer. 16,118.7. So at the end of the day, Newton is going to show you a process that's very algebraic. You can use Excel if you want, and you can use Excel in a trial and error approach, like I was showing you. It takes a little bit of getting used to because it's not an approach that a lot of people have practiced using in mathematics. But, you know, given that we have this calculator and the cell references, which will allow us to change the values and keep trying to adjust to get a better answer, it can be done pretty quickly. And in fact, I'm doing it with a sort of side-by-side approach, but you could do it with a table where you have your guess and your result. And I do, so let's say my guess was 16,000 and the result is equals this times 1 plus 9% divided by 4 raised to the 4 times 18. And then I can try a new value, 16,100, and I'm autofilling here to see. And in fact, I could, you know, with even actually just autofilling from here, I think it's going to count by ones. So then I'm like, oh, okay, I'm getting closer here, getting closer, getting closer. Yep. And then you can see I cross over in here, and now I can go more specific. Okay, what about 1618.5? And then Excel starts autofilling for me because it knows like, oh, well, you want something in that column too. 0.75. Right. So just using a table approach to kind of speed up the guessing and keep track of your guesses and see what the results are. Because sometimes I think that's easier for students to see what the outcome was and then kind of compare it and think about whether we need to go bigger or smaller. Okay, hope that helps. Give me more questions.